10th Standard Physics, Class 4. In this class, we will discuss let us assess questions of first unit, questions 5 to 10. You might have already written answers of these questions in your notebook. Check it and correct it if there is any errors. Fifth one, complete the table based on amperage of fuse wire. In this table, operating voltage, power of the device, current through the circuit, and amperage of fuse wire to be used is tabulated. There are some missing values. We must calculate those values. First of all, water heater. The water heater is operating at a voltage of 230 volt. Power of the device is given to be 4370 watt. Current through the circuit is given to be 19 ampere and amperage used is 20 ampere. Why a 20 ampere fuse wire is used even though the current is 19 amperes? Here, the water heater will be connected to the mains through a switch and a fuse wire. When the switch is turned on, 19 ampere current will be flowing through this fuse wire and switch and through this water heater. But when a 19 ampere current flows through a 19 ampere fuse wire, it would get melted away. In order to avoid this, you must use a fuse wire of amperage slightly greater than the current in the circuit. So we will round to the next whole number. That is, if you are getting 19 ampere as the current through the circuit, you will use a fuse wire of amperage 20 ampere, which is the next whole number. So here a 20 ampere fuse wire is used. Now second one, air conditioner. The operating voltage is 230. Power of the device is not given. Current through the circuit is 14.5 ampere. Here power can be calculated as P equal to VI. P equal to VI equal to 230 into 14.5. So this can be 230 can be rewritten as 23 into 10. So now you may multiply 14.5 by 10. So you are getting 23 into 145 equal to 3335 watt. Now the current through the circuit is 14.5 ampere. What must be the amperage of fuse used? Amperage must be the next whole number, that is 15 ampere. Now for a television, LED television, operating voltage is 230 V. Power of the device is 57.5 watt. What will be the current through the circuit? Equation is given here. Current is equal to P by V. Here P is 57.5 and V is 230. So the current will be 57.5 divided by 230. But we cannot divide 57.5 by 230 because 57.5 there is a decimal place in numerator. In order to make it a whole number, we need to multiply it by 10. So we will get 57.5 into 10 divided by 230 into 10. So 575 divided by 2300. Now this 575 is divisible by 25 and 2300 is also divisible by 25. So we may factorize these two values. So you would get 575 is 25 into 23 and 2300 is 2300. It is 23 times 100 and in 100 there are 4 25s. So you may write it as 23 into 4 into 25. There is an advantage of writing like this. You can see here the 25 and 25 would get cancelled. 23 and 23 also would get cancelled. As a result, you will be left with 1 by 4 alone. So without much calculation, you would get the answer here. So the answer will be 1 by 4. And you know 1 by 4 is 0.25 ampere. Now the current through the circuit is 0.25 ampere, which is less than 1. When the current is less than 1, here in 10th place there is 2. So you must take the next number, the next digit, next number in the 10th place. That is, instead of 0.2 ampere fuse wire, you must consider 0.3 ampere fuse wire. So the amperage must be 0.3. Here in 10th place, the number is 2. So amperage of fuse wire used is 0.3. Now computer, laptop, operating voltage is 230, power is not given, current is given to be 0.125 ampere. What will be the amperage of fuse to be used, and what is the power of this device? Power can be calculated as Vi equal to 230 into 0.125, that is 23 into 1.25 equal to 28.75 watts. Now, what must be the amperage of fuse used? Here, 10th place, we have 0.1. So, the amperage of fuse wire to be used will be 0.2. A 0.2 ampere fuse wire must be used in the circuit. 5b. The amperage of fuse wire used in a circuit that works on 230 volt is 2.2 ampere. If so, the power of the device is. We know how to calculate power. Here in this question, voltage and current is given. So power can be calculated if you know voltage and current. So power will be Vi equal to 230 into 2.2 watts. Again, this can be written as 23 into 22. This will be equal to 506 watts. But if you are using a fuse wire of 2.2 ampere, the maximum current flowing through the device will be less than 2.2 ampere. Otherwise, we cannot use this device. Whenever you switch on that circuit, if there is 2.2 ampere current, whenever you switch on the device, that fuse would get melted away. So, the current will be less than 2.2 ampere. So, the power also will be less than 506. That is, the amperage of fuse wire is 2.2 ampere. So, the current through the device is lower than 2.2 ampere. Hence, the power will be less than 506 watt. So, the most suitable option is second one, that is 300 to 500 watt. Question number 6. A 230 volt 115 watt filament lamp works in a circuit for 10 minutes. What is the current flowing through the bulb? How much is the quantity of charge that flows through the bulb in 10 minutes? A 230 volt 115 watt filament lamp. What is the current flowing through the bulb? Voltage and power is given. What? Voltage and power is given. So you may calculate current because we know power is equal to Vi. So I equal to P by V equal to 115 divided by 230, and 230 is twice 115. So we will get answer as 1 by 2 equal to 0.5 ampere. And in B, how much is the quantity of charge that flows through the bulb in 10 minutes? Quantity of charge. We know the relation connecting time, quantity of charge, and current. Current I is equal to Q by T. I is equal to Q by T. But here T is given in minutes. We must convert it into seconds. So 10 minutes is equal to 10 into 60 seconds. It's equal to, so Q can be calculated as IT. Q can be calculated as IT equal to 0.5 into 10 into 60 coulomb. That is 300 coulombs. Question number 7. An electric heater conducts 4 ampere current when 60 volt is applied across its terminals. What will be the current if the potential difference is 120 volt? An electric heater conducts 4 ampere current when 60 volt is applied across its terminals. What will be the current if the potential difference is 120 volt? We know here the voltage is increased from 60 to 120. So when the voltage increases, current also must increase. That is because I is proportional to V. And according to Ohm's law, I is equal to V by R. So using this Ohm's law, we can calculate the current in second case. In first case, 60 volt potential difference is applied and 4 ampere current flows. So we can calculate the resistance of the device, and while knowing the resistance, we can calculate the current in whatever situation may be. That is, in first case, V equal to 60 volt, I equal to 4 ampere, and V equal to IR. From V equal to IR, we can rewrite the equation R equal to V by I. It is equal to 60 by 4 equal to 15 ohm. So the resistance of the device will be 15 ohm. From second case, we know V equal to 120 volt. So I will be equal to V by R equal to 120 divided by 15 equal to 8 ampere. Eighth one, 3 resistors of 2 ohm, 3 ohm and 6 ohm are given in the class. What is the highest resistance that you can get using all of them? What is the least resistance that you can get using all of them? C. Can you make a resistance 4.5 ohm using these three? Draw the circuit. Let us consider the first question. 3 resistors of resistances 2 ohm, 3 ohm and 6 ohm are given in the class. What is the highest resistance that you can get using all of them? Highest resistance is obtained when the resistors are connected in series. So, in order to get highest resistance, we must connect this 2 ohm resistor, 3 ohm resistor and 6 ohm resistor in series. The effective resistance in series connection is R equal to R1 plus, R2 plus, R3. Let us consider R1 equal to 2 ohm, R2 equal to 3 ohm and R3 equal to 6 ohm. So we will be left with 2 plus 3 plus 6 equal to 11 ohm. Now, what is the least resistance that you can get using all of them? In order to get the smallest resistance, we must connect these resistors in parallel. That is, smallest resistance is obtained when the resistors are connected in parallel. In parallel connection, we cannot directly calculate the resistance. Instead, we are calculating the reciprocal of resistance, that is 1 by R. 1 by R is equal to 1 by R1 plus, 1 by R2 plus, 1 by R3. It's equal to 1 by 2 plus, 1 by 3 plus, 1 by 6. How can we add these fractions? We can add fractions only if the denominators are equal. Here 2, 3 and 6 denominators are not equal, so we must make it same. In order to make the denominator same, we know 2 is, when 2 is multiplied by 3, we will get 6. When 3 is multiplied by 2, then also we will get 6. That means 2, 3 and 6 have the common multiple 6. That is, 6 is the common multiple of all the three numbers. So we may take it as the common denominator. So Now you need to convert 1 by 2 to a fraction with 6 as its denominator. For this, you may multiply 2 by 3. While multiplying the denominator 2 by 3, numerator also must be multiplied by 3. That is, we may rewrite it as 1 into 3 divided by 2 into 3 plus 1 into 2 divided by 3 into 2 plus 1 by 6. Now, it will be equal to 3 by 6 plus 2 by 6 plus 1 by 6. You can add the numerators, so you would get 6 by 6. This 6 by 6 is actually the reciprocal of resistance, the reciprocal of effective resistance. In order to calculate the resistance, you must again take the inverse. So you would get R equal to 6 by 6 equal to 1 ohm. Can you make a resistance 4.5 ohm using these three? Draw the circuit. The possible ways to connect all the three resistors are either we may connect the resistors one after the other, or else we may connect one end of all the resistors together and the other end of resistors together. So in first case we are getting series connection, and in second case we are getting parallel connection of resistors. Is there any other methods to connect all these three resistances? There are. We may either connect two resistors in parallel and the third one in series with this combination. Here you can see two resistors are connected in parallel first, then another resistor is connected in series with this arrangement. There is one more way to connect these three resistors. In the last method, two resistors are connected in series. Then another resistor is connected in parallel with the first arrangement. Which one will be the answer to this question? Now you have already calculated this. In series connection, effective resistance is 11 ohm, and in parallel connection, effective resistance is 1 ohm. What about the, so 1 and 2 is not the answer required. So let us consider 3 and 4. Let us name the resistors in third figure as R1, R2 and R3. What will be the effective resistance of this arrangement? Effective resistance when R1 and R2 are connected in parallel. R1 and R2, let us consider R1 and R2 alone connected in parallel. The effective resistance will be R1 R2 divided by R1 plus R2. We have already studied. R parallel will be equal to R1 into R2 divided by R1 plus R2. With this arrangement, the third resistor R3. With this arrangement, the third resistor R3 is connected in series. Now, when it is connected in series with this arrangement, the effective resistance becomes Rp plus R3. And we know Rp is equal to R1 into R2 divided by R1 plus R2. That is R1 into R2 by R1 plus R2 plus R3. That is, effective resistance in this arrangement is equal to R1 R2 by R1 plus R2 plus R3. Now let us give values for R1, R2 and R3. Let R1 be 2 ohm, R2 be 3 ohm and R3 be 6 ohm. Then what will be the effective resistance? The effective resistance, we will get it as 2 into 3 divided by 2 plus 3 plus 6. It is equal to 6 by 5 plus 6. 6 by 5 plus 6 will be greater than 6. But in this question, we require a resistance of 4.5 ohm. So this is not the required solution. Now let us consider, let R1 be 3 ohm, R2 be 6 ohm and R3 be 2 ohm. Then what will be the effective resistance? R will be equal to 3 into 6 divided by 3 plus 6 plus 2. 3 into 6 is 18, 3 plus 6 is 9. 18 by 9 plus 2 equal to 2 plus 2 equal to 4 ohm. Again, this is not the required combination. Now let us consider R1 as 6 ohm, R2 as 2 ohm and R3 as 3 ohm. So just we are giving various values. We are assigning different values for R1, R2 and R3. Now when R1 is taken as 6 ohm, R2 as 2 ohm and R3 as 3 ohm, we will get the effective resistance as 4.5 ohm. That is, the required arrangement is given here. So in order to arrive, this is the answer for this question. Can you make a resistance of 4.5 ohm using these three? Draw the circuit. Circuit is drawn here. Also the analysis calculation is given here. This is enough for the examination. This is enough for this question. But in order to arrive at this answer, we must go through all the previous way. Ninth one. A girl has many resistors of 2 ohm each. She needs a circuit of 9 ohm resistance. For this, draw a circuit with minimum number of resistors. Here, effective resistance in series connection R is equal to R1 plus R2 plus R3 plus etc. When three 2 ohm resistors are connected in series, the effective resistance will be R equal to 3 2 ohm resistors. That means 2 plus 2 plus 2. 3 2 ohm resistors connected in series. The effective resistance will be 2 plus 2 plus 2. This will be equal to 3 times 2. So we are just adding 3 times 2. So 3 times 2 will be 6 ohm. That means if you are connecting 10 2 ohm resistors, the effective resistance will be 10 times 2, that is 20 ohms. And if you are connecting 15 2 ohm resistors, effective resistance will be 15 times 2 ohm. 15 2 ohm resistors in series, then the effective resistance will be 15 times 2, that is 30 ohms. Now, here we require 9 ohm resistance. So, in order to get 9 ohm resistance, how many resistors need to be connected in series? So, to get 9 ohm resistance, the number of 2 ohm resistors required to be connected in series will be 9 divided by 2 equal to 4.5. 4.5 2 ohm resistors need to be connected in series in order to get an effective resistance of 9 ohm. But 4.5 resistance, 4.5 resistor, it is not possible. So we may take 4 resistors and we may connect them in series. When 4 2 ohm resistors are connected in series, effective resistance will be 4 times 2 equal to 8 ohm. Then 1 ohm resistance is remaining to get 9 ohm, isn't it? Now, if you are connecting two 2 ohm resistors in parallel, then the effective resistance will be R1 R2 by R1 plus R2, that is 2 into 2 divided by 2 plus 2. You would get it as 4 by 4 equal to 1 ohm. So, when if two 2 ohm resistors are connected in parallel, you will get 1 ohm effective resistance. That is, effective resistance when 2 ohm resistors are connected in series is 8 ohm, and effective resistance when two 2 ohm resistors are connected in parallel is 1 ohm. So we would get 8 and 1. We would get 9 ohm resistance if these two arrangements are connected in series. Effective resistance when these two arrangements are connected in series will be 8 plus 1 equal to 9 ohm. That is, you can see the figure. Here you can see 4 2 ohm resistors are connected in series. So the effective resistance of this part will be 8 ohm, and 2 2 ohm resistors are connected in parallel. Effective resistance of this arrangement will be 1 ohm. So these two arrangements are connected in series. So in total, the effective resistance will be 9 ohm. 10th question. If a bulb is lit after rejoining the parts of a broken filament, What change will occur in the intensity of the light from the lamp? What will be the change in the power of the bulb? What change will occur in the intensity of the light? Will the intensity of light increase or decrease, and why? Here, let us consider the filament before breaking down. Here, these two red lines shows you the length of the filament. When it is broken, you can see there is no change in length, but when it is rejoined, a small portion of the filament would overlap. As a result, length of the filament decreases. If you are connecting any broken items, its length would decrease slightly. Now, when the parts of broken filament are rejoined, the length of the filament decreases. As the length decreases, the resistance of the filament also decreases. When length decreases, effective resistance also would decrease. But according to Ohm's law, we know when resistance decreases, current through the bulb would increase. When resistance decreases, current increases. And we know when current increases, power would also increase because power is equal to VI. That means when the broken filament is rejoined, the power of the bulb increases. As a result, bulb glows with greater intensity. And that is all for this class. We have discussed let us assess questions from 5 to 10. Correct it if there is any errors in your notebook and also study well for the examination. Thank you.